Hello, my fine friends. Welcome to another video about functions. Here we're going to take another step with functions, and we're going to discuss functions with parameters. We'll talk about what parameters means as well. That will probably help. This is a way that we can make our functions even more reusable. We've already seen this idea of reuse just with functions in general. Now we're going to make them even more reusable. We're going to sort of supercharge them. To do this, I want to write a short program. I'm realizing right now that I've still got the previous program here, so I'm just going to quietly delete it, pretend that you didn't see that. I know that you did. And what I'm going to do is I'm going to write a program that draws a series of parallel lines because I want us to look at a for loop again, just while we're here. Why not? So what my program is going to do is it's going to draw a series of vertical parallel lines from a starting x and y position. It's going to draw some number of lines with some kind of spacing between the lines. So let's do that. The first thing that I would need to do is I need a position. So I'm going to declare my position variables right here in draw because I'm not thinking about these parallel lines as something that I don't know that I'm going to move around on the screen or something. I'm just going to draw them each time through draw. So these x and y positions I can define right here. So I'm going to set its x to whatever, 50, its y to the center of the screen, I guess. I mean, these numbers don't matter too much. We can always fix them later. So that's where the lines are going to start. The first line will be drawn at this position. And then because I know that I'm going to want to draw a number of lines, let's say I'm going to draw 20, if I want to do something 20 times, I want to draw 20 lines, it's very, very likely that what I want to do is use a loop. I could use a while loop, but given that a for loop is the special loop for counting, and especially from counting just up to a number from 0, I'm going to use a for loop. So I need to use the standard for loop syntax here, which is that I write for, and then I have parentheses where I'm going to put in the various parts of what you need for a loop. The starting condition, as it so often is, I'm just going to set a variable called I to 0. So that's my counting variable that's going to count from 0 up to 20, which is the number of lines that I want. A semicolon. Then I have the condition that I want to check. So I want my for loop to keep going for as long as I is less than 20. That's what's going to allow me to draw 20 lines, right? I is going to count up to 20. Semicolon, and what's going to happen to I each time through? It's going to get bigger by 1. So I'm going to say I plus plus because that means add 1 to I. So now what we have here is a loop that counts up from 0 to 20. It's going to do whatever is inside its block of code, the curly brackets here. It's going to do whatever I put in here 20 times. This is what that for loop means. So what do I want it to do 20 times? Well, I'm looking ahead a little bit here, so I'm actually going to draw my lines, in quotation marks, as rectangles. Okay? So because I'm going to draw it as rectangles, I'm going to set no stroke as one of my drawing commands here, because I actually don't want a stroke, and I'm going to set the fill to white, because I want my rectangles to show up on my black background. It doesn't have to be white, it could be red or green or whatever you might want. Don't feel like you have to do everything I do. And I'm going to set my rect mode to center just because that will make it sort of feel a little bit more like, especially this Y position, like my rectangles are going to be centered on the Y position. Again, this is not the most important thing about this program. Then I'm going to actually draw a rectangle. So remember, we're in a for loop, so all of these things is happening repeatedly 20 times. So I will always want to draw my rectangle at the current X and Y position. That's the location. And then I need to make it look like a line. So I'm going to give it 2 pixels of width, and I'm going to make it 50 pixels in height. So it will look like a sort of skinny rectangle that effectively looks like a line, right? Then if I want all of my lines, my rectangles, to be drawn from left to right, side by side, I'm going to need to change the X variable so that the next time the loop gets through, because remember the loop's going to get down to its bottom curly bracket here, and it's going to go back up to the top, and it's going to do it again 20 times. It's going to repeat this code 20 times. If I want each rectangle to be to the right of the previous one, I need to increase X. So I'm going to say X equals X plus 5. So the next rectangle is always going to be 5 pixels to the right of the previous one. And that's my loop. So do this stuff 20 times. That's what my for loop says. And inside, what it does every 20 times is the first time it draws a rectangle at the original x and y, but then it increases x by 5, and then it goes through and draws another rectangle, increases x by 5, another rectangle, increases x by 5, until it has drawn 20 rectangles. Okay, so let's make sure that this actually does something. So let's go look at the program running. There it is. Actually, it looks like the MIT Press logo a little bit, if you've ever seen that. But we can see we've got 20 neat little lines, all drawn in parallel. Quite nice. And we know things, you know, the power of loops. We could, for example, go back, and if we wanted more of those lines, we know that our loop counts to 20 right now. That's why there's 20 lines. If I wanted 50 lines, I could just write 50 there. And then I have 50 lines. And then I'm greedy for more lines, so I want 100 lines. And then there's 100 lines, and they kind of go off the edge of the screen, off the canvas. So there's a lot of flexibility in what we can do with these lines. We also probably realize that if we change, for example, this number here, the x plus 5, that determines the amount of pixels between each line. So I could change that to 10, for example, if I wanted them to be more spaced out. There we go, now they're more spaced out. If I wanted to change how high they are, I could change this 50. I know that's the height of each rectangle. I could change it to 150. Now the lines are taller. So there's a great deal of flexibility. This is, you know, this is the power of programming in general. But the really important thing to notice about all of this is that I can only ever make these changes by changing these numbers. But every time I run the program, it's going to be the same. You know, it's going to be a static kind of program that always draws the same lines. Now, in the interests of just being organized, we know that this big set of code here, it's not that big, but it's big enough. This is all about drawing some parallel lines. So just because we know about functions, we should be thinking, I should move this into a function. So let's cut that with Command X, and I'm going to call my function parallels, and I'm going to call it there because I'm now going to define it. Obviously, I can't call it really until it's defined, but often I end up doing it in that order, just because that's where I am in the editing process. So here's my function definition of parallels. It's just that code that I already had, right? I'm just moving it into a function and then calling it up here. So we have the same program, and if we go and look at it, it looks identical, as you might expect. Now, one of the huge advantages of functions that we've talked about is reusability. It's true that I can call parallels again, and it will run the code in here again, which is nice. But if we go and look at it, you probably can imagine what this is going to look like. It looks exactly the same. Why does it look exactly the same? Well, because the code inside parallels is exactly the same both times. This set of parallel lines always starts at 50 and 250. It always draws 20 lines. It always draws the lines with the dimensions 2 by 150 in this case. And it always spaces the lines by 10 pixels. So if you call it twice, it's just going to do the same thing twice and effectively draw the same set of parallel lines on top of each other. So it's a good function in that it's modularized the code here. It's moved it into a named place, so my program is easier to read. But it's not such a great function in that it's not reusable. And when they can be, reusable functions are great. And this feels like a candidate because we're already seeing how if we change a bunch of these numbers, we can get the code here to do different things, and that suggests that it could be a reusable function. So what we really want is for parallels, which kind of draws a shape really, to be a bit more like the P5 shaped functions. So with something like ellipse, for instance, you don't just call ellipse, you call ellipse and you specify an x and a y and the dimensions of the ellipse, for instance. So we would like parallels to behave a little bit more like that. So how do we do that? Well, we do that we would do that by being able to give parallels some arguments, right? So for instance, if I wanted to specify where it should start drawing those lines from, I would want to be able to do something like this, right? Draw my parallel lines at this position, x and y. And the great thing about that, if I could do it, is that I could then say also, and draw another set of parallel lines, but start it at this position, right? And then parallels is reusable because I'm telling it, draw different kinds of parallel lines. One starts at 100 by 100, 100, 100, and one starts at 50, 50. And we would, in our dreams, because parallels would be a shape kind of like ellipse, it would just draw them at those two different positions. But that's not how this function works. The function definition for parallels does not know how to pay attention to these arguments. And that is where parameters come in. So when we want a function to be able to receive arguments, to be able to be told information about how it should do its job, we need parameters. And those are the things that we put inside the parentheses of our function definition. And you can see that it really corresponds to this, right? If we were to give parallels arguments, they would go inside the parentheses, just like with ellipse or background or anything else. So when we define our function, we need to say in these parentheses what kind of information is going to come in. And the truth of it is that when we're defining a function like this, what we write here, they're called parameters. So 100, 100 are called the arguments. They're the real values that we're sending to the function. When the function is receiving them in its parentheses, if you like, these things are called parameters. But what parameters are really is they're pretty much just variables, and they just have variable names. So when we write them, we actually just write the variable name. So we know that parallels is supposed to receive an x. That's the first argument that it would receive. So we have a parameter called x, and a comma, just like in the function call, and a parameter called y. These will be variables that will take the arguments when parallels gets called. So whatever the user of this function, ourselves actually, whenever we call the parallels function and provide numbers, those numbers will get stored inside these variables, which are called technically parameters. So when we call it with 100, 100, as we do up here, when it gets called, x will be set to 100 and y will be set to 100. And that's the little magical connection between a function call like this and a function definition like this. It moves, or like assigns, if you like, the arguments that we put in into the parameters. And it does it in the order specified, right? So parallels is 100 first, so that first 100 would be put into the x, and the second 100 would be put into the y. The next time we call it, the 50 would be put into the x, and the other 50 would be put into the y. That's how it works. Okay, so because we now have these wonderful parameters that will get an x and a y when parallels gets called, we don't actually need these variables anymore, right? We don't need to declare a specific x and y because now parallels relies on receiving an x and a y. And this is the powerful thing about parameters. So let's delete these declarations. We no longer need them. What we need is to make sure that we use the parameters x and y in the instructions of our function. And we know that we do because we had variables called that before. So we know that we draw the rectangle at x, y. That will be whatever the function was told were its x, y. So the first time 100 goes into the x and 100 goes into the y, so that when this function call is called, the code in here is run and x is 100 and y is 100. So this rect will draw at 100, 100, and then we will also increase the x that was provided by 10. So the first time through the loop it's going to go up to 110. Next time through the loop it's going to go up to 120, then 130, and so forth. So that is the wonderful connection. Let's go and actually take a look at that. And there we have it. You can see that we have two sets of parallel lines. I actually was not expecting it to look like that. Let's do some more, right? We can see that the one at 50, 50 has been drawn. It's drawn higher and further to the left because we gave it that x and y argument. And you can see it's drawn them along, spaced out by, 10 pixels at a time. And then the one drawn at 100, 100, just because of the numbers, is perfectly aligned with it here, which is neat. We can now call this parallels function anytime we want parallel lines like that to be drawn. Let's draw some at 200, 200. Let's draw some more at, let's do something a little bit racy, like drawing some at 312 and 57, just to throw its game off a tiny bit. Oh, very nice. You can see that now there's these little offsetty bits here. That's starting to look kind of interesting. Maybe I'm going to move that to 257 just to really ramp it up. There we go. So you can see that we're able to draw our parallel lines now wherever we want on the screen because we started using parameters with our parallels function. We added an x and y parameter, and that means that when we called the function, we can provide a position. This is the power of parameters. We can now use this function anytime we want. It is very reusable because it can now do its job, and in particular it can vary the position of where our parallel lines are drawn. And again, we're getting that amazing reuse thing just in general, that we're using parallels 4 times, right? Here there are 4 calls of parallels, but it's only one function definition. So we're getting to use this code in here 4 times, which is very, very neat and efficient of us. The reason that it's useful and the reason that we can use it 4 times is because of those parameters. It wouldn't make sense to call parallels 4 times if we didn't have the parameters, because they would just get drawn in the same place each time, right? Because we're able to pass through these arguments that set these parameters like they're variables, and then we use those parameters inside the function, now it's a very flexible function that is reusable. So it's a hell of a thing. I don't know what to tell you. It's a really amazing part of programming is functions with parameters. They are incredibly, incredibly useful and powerful. And in many, many ways, JavaScript is really premised on this idea of using functions in powerful ways. It gets super intense the more you know about it, but you can already see the huge benefits of programming in this way. Currently, parallels it's super cool, don't get me wrong, the fact that we can position these lines anywhere, but once you can start using parameters, you should start looking potentially for other things that might be interesting to make into parameters. So if we look at our code here, where would we look for candidates that we could turn into parameters? And there's quite a few. The obvious candidates are things that are currently numbers in here, or things that were previously variables, which is what we did with x and y. So we've got a number here, for instance. This 20 is the number of lines that we should draw. Why would we not want to make that into a parameter, right? That would make a hell of a lot of sense to make this a parameter. So let's do that. Let's add a parameter, and we can do that literally by just doing a comma and then adding another variable name. Let's call it numLines, because that kind of is a good name for it. And then let's replace this 20 so that instead of always being 20, it can be whatever the person using the function sends as an argument to this third numLines parameter or variable. So now it's got a numLines parameter. It uses it, so this is now the number that our for loop will count up to. Each time we call parallels now, we can specify as a third argument how many lines should be drawn. So if this one drew just 5, this one draws 10, this one draws 15, and this one draws, dare I say, 20. That's a bit lame, but I did it. Now if we go and look at our program, because numLines is now being set in the first one to 5, so the for loop does 5 lines. The next time it gets called, it does 10, so numLines is 10, and so the for loop runs 10 times, etc. We see that reflected in the number of lines that are being drawn. Here's the 5-line one here, here's the 10-line one, here's the 15-line one, and here's the 20-line one. So they're varying in their number of lines because we added another parameter. And we can do that with everything. So just quickly, because we can, here is the width of the line, right? So we could call this line width. It was 2, but we can make it what do you call it? A parameter. Good grief, a parameter. So line width would be another parameter. It would be the 4th parameter that we give it. We use it here in the rect, and we may as well change this 150 to line height, because that makes sense as well. And again, we need to make sure, and it's now, this one is the 5th parameter. So we've got line width and line height after the number of lines. So again, we can throw them in here. So I could say I want this one to have a line width of 1 and a line height of 100. This one is going to have a line width of 2 and a line height of something smaller, 20 maybe. The third one is going to have a line width of, let's get ambitious, 7. That's not that ambitious. And a line height of, let's be weird, 3. So it's going to actually be wider than it is high. That will look strange potentially. And this one is going to have a line width of, I don't know, 0.5. I don't know what that's going to look like. That might not work. And a line height of 300. I don't know what these are going to look like, but I'm just trying it out. So because I added yet more parameters, I can set yet more details of how these lines should be drawn. And these parameters are being used to draw the rectangles, so the rectangles are going to be based on whatever arguments get put into these parameters. There you go. So that's radically different now. It actually looks kind of cool. I'm not unhappy with this. So here, align height of whatever that was. I can't remember what any of them were anymore. Interestingly, that one where I set the height to be less than the width, here it looks like a dotted line, which is actually a kind of a satisfying outcome that I wasn't thinking of when I did it. And these 0.5 width lines look really nice as well. I guess they're being anti-aliased, so they're kind of gray here. So you can get some very nice effects by just changing how this function is working. There's one more number in here. Let's do it as well. So this 10 that we're adding is kind of like the spacing. So let's call it line spacing and add it. So it's the final parameter, line spacing here. And now each one of these needs a line spacing value. So let's say, well, we know that, and now we need to start thinking a little bit, right? So we know that the width of these lines is 1, so the line spacing should probably be greater than 1. So that, let's not. So let's set the first one so its line spacing is 1. So what's going to happen now? Well, because its width is 1 and its line spacing is 1, all of the lines are going to end up right next to each other, right? So if you go and look at it, and this is true of all of them, all of the lines are being put right next to one another, so you don't get the kind of extension across the x-axis. All of the other ones are having problems as well, and that's because we don't tell it what the line spacing is. And if you don't tell it what the line spacing is, there is no line spacing and everything kind of collapses. So let's make the line spacing of this next one 10, so that they're quite well spaced out. This one, the width is 7, so let's space them out by something larger. Let's space them by 20. And for this one, the line width is 0.5. Let's space them just by 1 and see what that looks like. Okay, so we've added a line spacing parameter. Now we have to make sure that we update the arguments that we're giving to the parallels function to take account of that, because we need the same number of arguments here, which is 6, as there are parameters to specify, which is also 6, because otherwise things can go haywire. We go and look, and this is what we end up with. So for instance, those 0.5 width lines, because I spaced them only by 1, now they're all kind of stuck together, because there's not enough space between them to actually see a result. So if I wanted to change that, instead of by 1, I could make it by 2, for example. And then I go back, and now there are little spaces between all of my 0.5 width lines. You can get some really nice effects by doing this, right? This is quite nice abstract art, if you ask me. So what we've done then is we've made a very flexible and powerful function for drawing parallel lines. You can imagine probably making more changes to this. There's the question, for example, of what if you wanted to draw your parallel lines horizontally instead of vertically. That's a whole other thing. But this hopefully illustrates the huge power in specifying parameters in your function definitions and using them in the code inside your function, and then making sure that when you call the function, you give it arguments that will be then set as those parameters when the function is called. It's a big deal. In the too much information category, there are questions around what happens when you don't specify one of the parameters with an argument. For instance, if the 1 is not there. The answer is that because I didn't specify it, line spacing here will be undefined, and that will kind of break the function. So it's really not a good idea to miss out on all of your arguments. In the even more too much information, you can look this up if you want to, or think about it. You can actually specify default parameters. So if the person using your function doesn't specify one of the arguments, it's possible to set a default so that the function still works. And there are some quite sophisticated ways. One of the things that kind of happens when we have a whole lot of parameters, as you can see here, and as you can see with the P5 functions too, is this is kind of hard to read. You've got to keep referring to this parameter list here to kind of know which number is which. And that can be a little bit of a pain, and there are some ways around that. There's a thing called object destructuring when you are specifying parameters. You could look that up if you want to look at something very advanced, but it's also super useful. So that's kind of it. That's it for me talking about functions with parameters. I hope you've seen just how exciting and like how much potential is available in this idea. And of course, you should be trying to use them moving forwards as much as they are relevant. Okay, I'll see you in the next one. Bye for now. Bye. Stop recording. Okay, I'm going to stop recording. Bye.